My name is Tziahanas. I'm the managing partner for a consulting firm called Sohosquared. You may have heard of us previously referred to as CapEx. We're in the process of doing some rebranding. We focus on information risk and information insight use cases. Lucidworks is a big partner of ours, and we do a lot of work with Lucidworks. And so one of the things I wanted to talk about was how do we actually see and use signals from a Lucidworks platform, and then also kind of more conceptually, what does signals really mean? And how do you use and derive them in real use cases? And so what I'm gonna show you today is actual data that we have from our clients, completely blocked out and abstracted where it's appropriate, but you'll understand how we're actually looking at it and how we're considering signals. So the first way to think of it is there's a capture component, there's an analysis component, and then there's an act and learn component. So the first thing you have to think about is, well, what am I going to capture? Some of this might be automatically captured by Fusion. Some of it might be automatically captured by App Studio to the extent that you're using it. But you have to think about, well, what information is interesting to me and that I can drive action or decisions around, and then I can analyze data. The analysis actually can almost live apart from Fusion or from any other application you're looking at. It's really behavior of how people are searching, what they're looking for, and as you'll see, the kinds of responses or requests or things that the signals tell us, right? So it's really trying to understand what we can learn and then act on that learning. And so that's where the action around models, using them to boost, or other things that we'll talk about in a moment. So really, you have to almost go back and think about information theory, right? Which is really where signal analysis started. And so Claude Shannon, very famous, developed the concept of information theory. He was trying to understand that signals arise at one point and you're trying to understand what they mean somewhere else. And this was coming up in the context just after the Second World War, and you started to see things like sonar and radar came out. And so you had all these signals actually starting to be developed in different forms. And the question was, how do I determine what a signal is from there, receive it in the sea of noise? And so he developed this concept of information theory. And so this model really is kind of interesting because today we're still basically using this model in all of our applications when we really think about the value of information and what is a signal. And so this model is actually from his original paper. And so the only thing that really matters is, think about it, there's a transmission source, there's a signal being generated, and there's a point where I want to capture that signal so I can do something with it. But what he realized was that in the middle of all this was always some sort of noise source. And this is what we're also dealing with. We have so much information. We have so much information that is meaningful or meaningless, and that actually impacts our ability to derive value from the data. So the other reason, though, that we can start to think about this in a slightly different way is, and I don't know how many of you know this, but since 2003, the world economy produces more transistors, which are the components on a chip, at lower cost than grains of rice. So for almost 16 years, we've been printing and producing more transistors at lower cost than rice. That really is all about compute, that's all about power, and it's all about our ability to actually analyze huge volumes of data. And so we see this manifested itself from the transition, of course, from vacuum tubes, as we then go to CPUs, GPUs, and things like FPGAs. Each of these now kind of has its own basis in how we analyze data, how we model data, and how we evaluate and derive models based on that data. So those of you who are actually really in the trenches executing and delivering, you're going to see that most of the time you're developing and deploying solutions that are really based on our ability to process data in CPUs and in memory. When you're looking at developing models and you're doing a lot of the machine learning and really developing models at that level, you'll actually start to see people and have been using GPUs and FPGAs. And so you have to start to think about, am I actually developing a whole lot of new models? That actually implies a different hardware architecture than if you're actually executing. So I just wanted to bring that up because it's kind of interesting. Each of these, all of it, of course, is really still based on the fact that we have consolidated huge volumes of transistors on very, very small chips. So we look at using signals then in three ways, as I talked about before. There's really the analysis and the insight component, there's the capture component, and the action component. And in the analysis component, this is where you start to learn about how users are engaged in search, what kinds of things that they're doing, and start to understand relevancy at a high level, right? Before you take any sort of action, you really should be analyzing what people are actually doing. Again, what is it that we want to capture, how we want to aggregate that data, use it, report on it, and then finally, what actions do I want to take around it? This is an example of some of the kinds of signals that we were capturing and have captured with our clients, and what value do they actually bring, right? So I can say we want to capture click signals or annotations or the types of events. Well, what value does that actually bring, and then who's going to use it? I think everybody in this room, if I were to ask you to raise your hands, how many of you are really IT-centric, IT-focused? Is it the majority of the group here? How many of you are like business analysts from the business, marketing? Okay, good. So this is where it's really important. I can capture all kinds of things, but what value does it provide to somebody making a decision from a product perspective, a business perspective, getting to the content perspective? So now I'm going to start to show you some of the kinds of things that you can actually get out of this data and how you can start to develop some sort of meaning. Of course, there's some basic things that Fusion will do for you, right? And the very simple things like just understanding traffic and query timelines. Well, when are people actually executing lots of queries, right? Does this actually correlate to the same things I would see when people come to my website or my enterprise applications? And does this allow me to actually think about, given the time and when people are engaged, can I segment them? Are they different? Do I want to promote something different based on the time of day or the day of the week? And you'll start to see day and time analysis as well. So based on the time of day and then the day of the week, that could be interesting as well. And it's just one more set of data that I can correlate to the rest of my applications. High level stuff, but still interesting. And again, it's another data point for you to correlate. And then response times. Users, as you know today, whether you're talking about somebody on a business, on a e-commerce site or in an enterprise, don't want to wait for anything, right? So can I actually just see that my queries are executing appropriately? This is an example of actually a fairly large client and their data and showing that they're getting very, very good response times. So when we start to analyze the data, before we do anything else, before we start thinking about all the different machine learning that you can start to enable, you start to do the basic things, right? Which is first, well, how are people actually using search? And what are the kinds of distributions around search? Look at the top 25, top 50, top 100 results. In e-commerce sites, we're actually seeing the top 25 or 50 searches with appropriate synonyms, sometimes will comprise 25, 30, or 40% of all the searches, right? So just 25 to 50 terms represent a huge plurality of the data. Well, that actually gives you a lot of power. There's a lot of things you can do very basic, and then there's a lot of things that allow you to then use and leverage machine learning because you don't have this crazy distribution. So this is an example of where you start to see, we have term A, which had a very high hit rate. The second, the third most popular queries, though, had a low response rate, right? So that's informative to us. So in other words, the number 2 and number 3 search terms had a very low click-through rate. Well, why is that, right? Maybe the content was terrible, maybe the page was terrible, who knows? But there's a reason for that, and you want to go dig into that. So before you even enable any machine learning or do anything else, those are the kinds of things you want to determine. We also found that things like this process, and I've changed it a little bit, but it's effectively an enrollment process. There were 4 terms that were very common in this enrollment process. Well, 3 of them had very low response rates. 1 had a high one. That's an excellent example of where synonyms were a really good alternative, right? And so all of a sudden, those 3 with poor responses get mapped to the 1 that had a good one. And before you know it, now, again, you've very simply and easily solved that particular problem. One of the things we've also done is started to actually look at the distribution of queries and clicks, right, within a position. This is not out of the box. We're happy to do it for you, though, for a fee. And so the But it's really important. What's really nice about this is a really clean distribution, right? So you execute a search, and the distribution is basically showing you that the majority of the people that actually clicked on this, right, clicked on either number 1 or number 2. It means that your search results are really good. The results were up high. That's where they searched. And the next one, though, you'll start to see, well, this distribution's not as good. And so that's great. So first thing is, you can say, well, we got to start working on this distribution. What do we do to actually promote the right results? The second thing we found, though, talking with the business team, was the number 1 and number 2 results that people were clicking on were not relevant, actually. Turns out that's not where the business wanted them to click. But because we're so used to clicking the first or the second or the third thing that we see in a list, people were actually clicking on the wrong thing, got upset, and just disappeared, right? So even though you think that number 1 and number 2 are appropriate, you always still have to go back and say, or were the best results, you always have to go back and say, does it make sense? Is that really where we want people to go? And this is where data is important, the data that you have, but also the curation of the data. Is somebody actually paying attention to this? And this was a really good example of where Boost with Signals out of the gate, if we had done nothing else, it actually exacerbated the problem. So we could have turned on Boost with Signals right away and just made the problem worse. That's why we're always trying to do the analysis before we start enabling the machine learning. This is a great example of where you've got the distribution, of a high value document here, and then some simple boosting would move this up, or certainly boosting with Signals. Now, the other thing that the reason that we use this distribution is because this allows us then to see changes and their impact over time. So if you see a distribution like this, in time, if we do the right things, and it would always be a combination typically of synonyms and potentially boosting and changing some query rewrites or head-tail analysis, you should see the distribution change so that these the bars, right, get higher back over to the left here and lower to the right. And that allows us to see if the changes that we're making actually made any difference. Similar kinds of things, and I'm trying to think, there was one more. So here's a good example, right, where when you look at the distribution of this at first, you're like, okay, well, clearly we have some work to do on the distribution. But what was more important here was it's actually a fairly, again, highly executed query, right? The term was fairly highly executed, but very, very low click ratio. And so in this case, we want to see what is in position 5, because maybe that will start to give us an example of what it is they're actually looking for. And maybe there's a reason that we can't get these folks to the right content. And then we also did find that eventually there were some synonyms that we could add from some of the other terms upstream that were actually correlated with that document. Again, similar kind of distribution here. And again, what we're looking for is how is it that we can change the results so that we're constantly pulling the bars to the left. In this case, boosting turned out probably to be the right approach. Again, this is another great example of where boosting with Signals turned out to be a pretty good idea. Okay. And then finally, this was actually after we proposed some basic changes, hadn't enabled any of the machine learning yet. We actually had suggested that they change how, and I've changed the word here a little bit, had to do with some secured credit. This is a banking site. That by changing a few things in the site, a landing page, and I think some synonyms, or a query rewrite, we saw this distribution after the recommendations were made. And this is exactly what you would want to see. Higher click-through rate, good distribution. So what we then do is we then basically are doing a Pareto analysis at this point, right? So now we've taken what are about 100 of these terms. They're looking, I guess this was the top 2% of the queries. And what we're trying to do is identify those that had the highest volume and the lowest click ratio. And all we're doing in a Pareto analysis is, again, you can try and surface everything in the ocean, or you can say, I'm going to focus on these things. In this case, we're looking at the top 2% of queries ended up having a material impact, right? Because you're looking at 10% roughly of the total volume of queries. So if you can just look at those, you're going to start to have a real impact, and then you work your way down as you would in any Pareto analysis. This is an example of the kinds of data that we generate. We're taking this offline to develop this basically analysis, but all of the data is being generated within Fusion, obviously, or we're capturing this within Fusion. And just so you guys don't think that we only can deal with things that include a search term, you can also look at things that based on how people are actually filtering or faceting with data. And this is an example of where we have a client that has one particular application that has a lot of filter and faceting. And you can actually see that the frequency of certain combinations is very high. In particular, right, we see a large population of certain queries faceted, or basically filtered and faceted, and then what percentage that correlates to. And it's a very high percentage, actually, so which actually was surprising to us. And then some other popular filter combinations that we were able to identify through the same kind of analysis. Now, one of the more important pieces of analysis that we do is what leads to nothing, right? So we've been surprised actually with a number of our clients where the population of queries that lead to nothing is actually quite high, which you wouldn't anticipate in a couple of instances. One was a commerce context. Searching for some fairly common things were leading to nothing, and it gave us a sense that there was a problem with the data and the way the data was being represented and indexed. In this case, this is a little surprising to us, again, because it's very faceted and filtered in the context of how the query is basically being passed into Fusion. But this gives you tremendous, right? So 57,000 of 180 queries lead to nothing. You have tremendous ability to all of a sudden make a real impact. So always look for what's yielding nothing. And just a few more, because I'm looking at my time here. Some additional kinds of examples of what we're pulling out here, looking at distribution of queries, what their volume is, the percent of that total, right? So in this case, you're looking at the top 200 queries as a third, and then what the click ratios are. So with this, I'll go ahead and take a few questions because I'm going to be out of time. Yes?
What do you find of all the different sorts of metrics they look at and analysis resonates the most with in terms of business value or value? What are they most interested in?
I would say the one for sure is, and the one that's surprising all of us and our clients sometimes, is that we get that many results that yield nothing. And that's the highest value that you can immediately impact. And then I would say that and actually Fusion's pretty good at this. If you look at the number of people that actually execute only a single term or two-term searches, that's a huge percentage, right? And so the next thing is the ability to develop like some synonyms or some basic landing pages can have really high impact long before you start executing the really cool stuff in the machine learning. And I think I showed you that example. It was in a banking site, just correlating 3 or 4 terms that were associated with a particular product offering, that 3 of the 4 were yielding poor results, but really just mapped to the other one. That was enough to yield really good results.
So you mentioned doing some of the easy, low-hanging fruit first. How often would you say, when you're getting new clients and such, that curating their data winds up being the most prevalent?
We use data to help us demonstrate that, right? Or you can start to see through the analysis that, and we have another client that the problem's not the machine. The problem is they have millions of pages of largely irrelevant data to 80% of the population, right? Of who's using the application. And it's a harder problem to solve because they understand that then, they conceptually get it, but then it's like, okay, where do I go within my organization to delete 80% of this stuff, or trim it, or remove it, and that's a harder conversation. That gets into the whole data governance discussion that I think people are really struggling with as we start to really reach into the organizations. Excellent. Well, my contact information is right there. Easy, George T. at Sohosquared. You're always welcome to call me or get in touch with us at any point. All right, thanks.